Do you see this one, the PDF file?
Yes, sir.
Okay. So, all right. So, as of Monday, we already formed 12 groups. No? So, an equivalent of 36 students already have their own groups. So, currently, as of now, we have 51 students. All in all, lahat kayo 51. So, there are 5 more groups to be formed. Okay? So, yung mga dalawang estudyante lang last time, hindi ko muna sila kinount as one. So, kailangan maging makompleto muna kayo. Okay? So, for those who do not have their groups yet, please just and you can already form your groups. Please type your names in the chat box. Okay? Isa lang kada group para hindi siya para no double counting. Okay? So again, for those who do not have their groups yet, you may do so, and then please, if your group is already complete, please type your names. Just your surnames would be all right na. Just type your surnames on the in the chat box. Okay? So let me now proceed with the guidelines for the design project. So the guidelines, it's pretty much the same as what I have been doing the past 2 years. No? So whatever I require during those past semesters, I also require it here. The only difference is that the number of members. Okay. So last semester, I let them do the project by pairs. And this time, due to time constraints, the project will be done by threes. Okay. So the design project is the biggest mandatory course requirement here, apart from the examinations. Okay. So the aim of this activity is to apply the concepts you learn during your study in this course. Please lang na, huwag niyo akong mute. Okay? Please don't mute me. Okay? So, again, so the aim of this activity is to apply the concepts that you learn in this course to design an actual, not really an actual, no, to propose uh, a design of a certain structure, no. So you will, for example, you find a place, and then depending on the community around that place, you will build something. Not really build. You will design uh, the building that you want built there. Okay. So how again? So this project will be done by threes. So the members must have three group members each. So each group will select a structure to be designed in the following using structural steel. So we have hospital, school building, or low-cost high-rise housing. So here are some of the required features that I have to see in your design project. Okay. So for hospitals, it would be this one. For school buildings, it's this one. For low-cost housing, it's this one. Okay. So now I want this to be divided equally into the groups. So I will be the one to assign you to a certain structure. So I will do this later on. Okay. So structures to be designed should have, aside from the listed features above, other facilities or features that are usually present on this structure. So for example, for hospitals, you design it like a real hospital. So it should have an operating room, clinics, ICUs, other facilities that are usually present in hospitals. Same thing with school buildings. It should have, say, classrooms, faculty rooms, libraries, laboratories, etc. Okay. So groups may also add other features which may be helpful on the functional capabilities of the structure. When we say functional capabilities, the usage. Huh? So I will discuss about this more later on. Okay. So the format for the design project is pretty much the same as the capstone. So it will have 5 chapters. So I will present a sample manuscript later on. So the design should compose of 2 parts: the functional or conceptual design and the final design itself. So functional design, when we say functional design, you will conceptualize the design itself. So what do you include here? The proposed location, the schematic diagrams, meaning the building plans, or as we call it, architectural plans. However, I avoid using the word architectural. Okay. So we call them, in this class, we call them building plans. Okay. So facilities present, technical and economical feasibility. This one is the constraint and trade-off. So I will explain this later on. How do you format this one? Including a review of related literature related to design and construction. Functional design should adhere on applicable standards, codes, and laws, such as but not limited to NBCP, the building code. So as far as I know, you already learned about this one during your building design classes. Fire Code of the Philippines, Accessibility Code, uh, in school building design, you also use the DepEd Educational Facilities Manual and other manuals that may be applicable in your design. Okay. Then, aside from that, references on architectural planning and design may also be used. You may also seek help from architectural students as to how to do your schematics. Okay. So then the last one would be the final design. So this now includes the structural design itself. So we have the structural framework design. So the format for the structural design calculations, we will refer to the asset checklist or structural design documents. So this one, you may search them on Google. So maraming nagkalat dyan. Okay. And at the same time, you will also produce the blueprints of structural plans. Uh, you don't have to print them. You just save them as a CAD file and PDF file. Okay. So usually in other design projects, they do not include the plans. But in this class, we will include them because you cannot actually construct a structure using the calculations. You need to translate those calculations, those analysis and design that you have done into something that many more will understand. So in this case, we will be having the plans or the blueprints. Okay. So okay. So final design should show not only the software inputs and calculations, but also manual calculations. So in in designing the members, no, So you will perform manual calculations. The software calculations, you will only use them as a for comparison purposes, whether you are doing the right process or not. Okay, and but then in structural analysis, for example, if you want to determine the forces on each member, well, you will use the software. No need to do the manual. You will only do the manual calculations during the design using the forces that you determine from the structural analysis using the software. So manual calculations, you may perform either hand calculations or you may automate your own calculations using Excel or MATCAD. So usually they do Excel files. So you make your own Excel spreadsheets. I do not recommend using other people's spreadsheets precisely because they tailor fit it to their own needs. So it means that it does not necessarily fulfill your design needs. So you need to design your own spreadsheets. Okay. And then the final design of the structure should adhere on applicable standards, codes, and laws such as the 2015 NSCP. Okay, not 2010 anymore. So 2015 NSCP, the steel construction manual, the detailing manual, etc. So another note here in making structural plans, you need to adhere with the AISC steel detailing manual as well as the format prescribed by the National Building Code. Okay? So however you arrange the title blocks, the figures there, you should follow the standard rules. Okay? So it has to look like one of those plans that you see in at work. Okay? So now I will so do you have any questions so far? Do you have any questions? So if you have any questions, please send it to the chat box as well. Okay? So so that I can get back to it. Okay? So let me present you some sample manuscripts that were done last time for the design project. So I credit it to my students last semester, no? More especially to those who made the manuscripts. So they have already graduated. Okay, so do you see this one, the Google Drive? Okay, so right, so I have two manuscripts here. The one by Asilo and Villania and the one by Barcelona and Cantina. So I will show you the one by Asilo. So the first page that you have should be the design experience information. So this one has the same format as that of for the capstone design. So they lay out the constraints, the trade-offs, the quality standards, etc. Okay. The rubrics don't need to attach them in this case, so they just attach it because they don't know what they didn't know what to do at that time. No? So they just use the same rubrics as the one used in capstone design. However, in this case, no need to attach the rubrics. So this is the table of contents. So this one is the intro. So pretty much the same. No? as that of the capstone. Background, location, project client, client specs, objectives, scope and limitation, and the project development plan. Okay. Next is chapter 2. This one I am a bit stricter about this one. So the first thing that I want to see is the location data. Okay, the vicinity map, the demography and socioeconomic data, topography or topographic map, no? Hazard maps. So hazards, there are many types. No, the landslide hazard maps, flood hazard maps, ground shaking and rupture, uh, landslide, so rain induced and earthquake induced. I don't think they have the liquidation hazard map, no. But then I also want you to include them, okay? And also the wind hazard map. Okay. So the reason for this is for you to consider additionally the hazards that may put the structure at risk of damage. Uh, So you will also consider the effects of these hazards on your proposed structure. Okay. So the geotech report, I'm not really strict on this part because I understand that some of the LGUs do not readily give out geotechnical reports. So for now, for example, if you have a location, you just have to find a uh, a geotech report on that location. And at the same time, I want you to search for the geologic map and the soil map from the Bureau of Water and Soils Management of the Department of Agriculture. So those things, no. So if you don't, but then I usually prefer the engineering geotechnical report, no? The one with the boreholes and the tests and the whatever recommendations they have. Okay. Then, so that would be all for the location data. So everything about the location, it has to be complete. And I recommend that you also use this format in your capstone design projects. Uh, because one thing that I observed, especially when I was an internal advisor, is that the location data is always incomplete in some way. Uh, this forms the basis as to why do you want that structure to be built at the certain location. So this forms the basis. So meaning if you don't have this, it will be hard to convince anyone to invest on your idea to build a structure there. Okay, so I want this complete. Same thing with the other parts. No? So we have the description of the structure and the building plans. So again, I have I have told you earlier, do not call them architectural plans, no? Precisely because there is an ongoing conflict on the delineation of the architecture and civil engineering disciplines here in the country. No? So as a form of respect, we just call them building plans. No? We do not have the license. We are not allowed to practice architecture unless you have your architecture license. No? So the description. So I will show this one in detail later on. The building plans. So you have the site development, the perspective, the floor, ceiling plans, elevation sections, schedule of finishes. Only building plan. I only require the building plans precisely because you do not have the structural design yet. So you cannot make the structural plans yet. So you only have to have your building plans. Okay. Next, the design loads. So this one should be based on NSCP 2015. Okay, so the dead loads that you use, the live loads. So the dead loads usually are usually due to the materials that you use. That's why in building plans, this part right here, the schedule of finishes is important because it forms the basis what dead loads do you have. For example, if the floor finish is tiled, you will is made up of tiles, for example, then the dead load, one of the dead loads that you must consider is the tiles. Okay, and so on and so forth. So that's why I want the building plans complete in order to form the basis on the design loads. Okay. Then we have the live loads. It depends on the function of the building. That's why the floor plans must be complete. Okay. Wind loads. So the wind load determination in 2010 NSCP and 2010 NSCP are different. So I want you to use the 2015 NSCP in this portion. Okay. So one major difference is the wind maps. In 2010 NSCP, they only use three zones, zonal maps. However, in 2015 NSCP, they now use contour maps. Okay, so I want you to use the 2015 NSCP provisions for this one. Seismic loads, well, just like what you learned in earthquake, you use that here. And then the others, please mute your microphones. You do not have anything to say. Okay, so okay, so let me resume. So then we have the gravity load distribution maps or the load mappings, both for the live load and the dead load. So I will show an example of this later on. Then you have the review of related literature. This one is also a bit tricky in this case because you need to find the reference that is related to your design. Okay, so both local and foreign. So many of you struggle in many of my past students struggle with this one. Okay, so what exactly do you put in your RRL? Now, I only require at least 10 papers or technical journals. No? So, you, you may decide how many is local, how many of that 10 is local, how many of that 10 is foreign. I understand that there's pretty much a shortage of local literature. No? So, we do our country do not produce much literature related to civil engineering. There's not much foreign. However, there's not much shortage. You just have to to find. Okay, so one search engine that I recommend to use here is the Google Scholar. Okay, precisely because Google Scholar also verifies the quality of the papers that are there. Okay, unlike if you just search it in on Google ordinarily, you may stumble upon the papers that are not really well written. Okay, so that that's that would be it for the review of related literature. So, do you have any questions so far? Okay, so I checked the chat. I see there are no questions so far. Okay, so for the chapter 3, the constraints and trade-offs. Okay, so pretty much the same as in the capstone. So the only difference is that uh, we only limit our context to one, which is the structural context. Unlike the capstone design, you're required to do two design contexts. No? Here we only have one design context, precisely because this is a structural engineering course. So meaning you only have to do the structural context. So we have the quantitative and qualitative constraints. So I require only three quantitative and at least three quantitative and three qualitative. Okay. And I also want the parameters for each quantitative constraint to be of the same unit. So if you observe this one, economic, constructability, and sustainability, they are all expressed in terms of cost. Okay. So the others, for example, constructability, they use say project duration only. Okay. So that's project duration as a different unit compared to material cost. So it would be a bit harder to compare them. Same thing with sustainability. Usually they use deflections or lateral drifts, which is a bit hard to compare to material cost or project duration, for example. So you have to express all of the quantitative constraints. You have to measure all of these quantitative constraints into a single unit, something that would be easier for you to compare. So in this case, in this particular manuscript, they use cost as the common unit. Okay. Qualitative, these are just the constraints which may affect your design, but you can't measure it. Okay. So meaning, if you assess your trade-offs, you can just assess the these trade-offs in terms of these qualitative constraints only in words, no? Na you cannot measure anything. So for example, social constraint, aesthetic constraint, this is not something that you will be able to measure, but you are sure that there will be an effect, that each trade-off will present a significant effect on these constraints. So for example, excuse me, if you compare, say, two framing systems, one is a moment resisting frame, one is a brace frame, which one is more visually appealing, for example? So that's a comparison in terms of aesthetic constraint. Okay. Same thing with the environmental constraints. So again, for example, for beams, you use W section, and for the other one, you use HSS. Which one is more environment friendly, for example? So that's not something that you can measure, but still you can make a comparison. Okay. So back to this, I require at least three quantitative constraints and three qualitative constraints. Okay. The trade-offs. This one, if you observe, there are trade-offs for each component. So I want you to do the same. So for the framing system, for the beams, for the columns, for the bracings, for the truss members, for the and for the connections. So there will be trade-offs for each of them. Okay. So for example, in framing systems, they use SMRF, eccentrically brace frame, and concentrically brace frame. Okay. So There is a list of structural systems that you may use, okay, in NSEP, so you may refer to them. So in framing systems, I want you to propose at least 3 trade-offs. And then for the beams, the columns, the bracings, the connections, at least 2 trade-offs each. Okay. So now, what do you do with this one? During the initial rankings, you will combine each of them. So for example, one set of trade-off would be SMRF with rolled double section beam with rectangular encased I-section column with single diagonal bracing and with bolted connections. So that is one combination. For example, combination 2 SMRF, roll double section beam, rectangular I-section column, single diagonal bracing, welded connection. That's the second combination. And you combine them until you complete all of the combinations. So in this case, we have 3 times 2 times 2 times 2 times 2. You will have 48 combinations. However, rest assured that you will not design all 48 combinations. Okay? So what will happen is the initial rankings, the initial estimates, you will assess the 48 combinations, and then from there you will pick the top four combinations. Then that's the only one those are the only ones that you will subject to structural analysis and design. Okay? So again, although there are 48 combinations here, you are not required to design all 48 in chapter 4. So you will do your initial rankings, and then you will only design the top 4. Okay? And then the design codes and standards. So what codes you will use here? No? And then the chapter 4, the design of the structure, I also want you to be a bit stricter here. So first, they have the design methodology, and then the structural analysis for each trade-off. Okay, and then the design. Okay, and material takeoff, and then the final rankings, and then the final design. So let me go through this one. Okay, so let me show some examples on how you do each section. So here, this is the chapter 1 is just the same as that of the capstone. Chapter 2, here's the location data. So first, the vicinity, uh, demography, and socioeconomic data. So they only have the population here now. So topography. So here's the topographic map. So they cannot acquire any contour maps either from NAMRIA or from LGU. And then hazard maps. So this one you may obtain them either from the LGUs or You may use the Project NOAA of the DOST, DOSTUP, and other related government agencies. So there, then the distance from the nearest fault, then the geotech report. So I don't want you to copy paste the geotech report if you have one. No, you need to uh, to summarize them, to paraphrase them. So in this case, although they have the original copy of the report, they tried to summarize the findings. Okay, and then so if you observe, there is ASTO instead of the USCS, precisely because this one is for highway construction. So it is better to use the USCS soil classification. Okay. Now, if you only have the ASHTO, but you will use it for building, so you need to make your own. You need, based on the geotechnical test results, laboratory results, you need to classify the soil. Okay. Then they have the geologic map here. There you go. So description of structure. So it is like this. What are the features for each floor, so on and so forth. So here the general description, and then the makeup of the structure, what are the facilities, and then the grid lines here, it's based on your plans. Okay, and then there's the plans. So I have a bigger copy of this one, so no need to yeah. Okay, so then the loads, you need to explain how you determine those loads. So for example, dead loads, you show this one. Okay, the live loads, it is better to show where did you find them. So they cited the section, the specific section where you can see this. The wind loads, these are the parameters, and then they explained how they obtained these parameters. There, the wind map, so there's the project location, and there's the contour map. So this one can be found on 2015. Now, if you use 2010, it is a bit different because there's only 3 zones. So I don't want you to use that. Now, wind maps here are different depending on the occupancy category of your building. So for uh, category 1 and 2, it is you use a different wind map. For 3, 4, and 5, this one. So in this case, this one is standard residential building. So they use, I think that would be category 4, I think. No? So since it is in category 4, you use this one. Okay. And then there are the values, the wind pressure coefficient, wind pressure coefficients, etc. Seismic load, same thing. You need to explain how you obtain them, and how you obtain these parameters. And then the seismic map. So here's zone 2, zone 4. Okay. So the load distribution maps, or the load mappings, well, just like when you were in kindergarten, you just do some coloring. Okay. So this color means the live load. So this one is for the live loads. So here, this color here signifies that the live load here is 1.9 kPa. And then for the balconies, you use 2.9 kPa. Okay. So for the dead loads, everything is 4.42. Okay. So that's one example of load distribution. Okay. Then for RRL, I want you to do not just enumerate the papers that you were able to find. I want you to consolidate all of the ideas that you have obtained from those papers, and then make a summary, an annotation of what are the about the ideas that you have found from those papers. So they put it in this way. So this one is a bit good. No? So again, as I have said earlier, there are many students who struggle with this one. Okay. So now, this one is also important, the review of related literature. Why? Because this will be the basis on how you select your trade-offs based on your constraints. Okay, so for example, based on their RRL, bracing is highly efficient uh, to resist loads due to wind or say earthquake. That's why in their trade-offs, they propose brace systems precisely because they found out from their RRL that bracing is a good method to resist lateral loads. Okay, so that's one example of how important the RRL is on formulating and determining your trade-offs. Okay. Then for chapter 3, here are just the constraints and then the trade-offs. So here you select the trade-offs based on what you have found out on your RRL. That's why again they have the brace frame system. They propose using brace frames precisely because again based on their research, their RRL brace frames are effective framing systems for resisting lateral loads. Okay. So you just put the advantage and disadvantage of each trade-off. And then for the beams, the columns, everything. No? And then here's the ranking. So they rank each trade-off. Okay. And then where should I see them? Yan. This is what I have. This is what I mean when I said that you need to combine each trade-off. So in this particular case, they have around 40 combinations. I have said earlier that there are 48, but that's not necessary because in SMRF you don't put bracing. Okay, so you combine each trade-off and then you will determine the initial rankings based on what you have found out. So the trade-off results, it was found out that the top four prospective trade-offs that would win the design are these four combinations right here. Okay, so that means you will only design these four. The rest, you don't need to bother about them. Okay, so and then the design codes here, and then the particular sections that you need to use. And then chapter 4, so here they explain how will they go around with the structural analysis and design process. And then the flow charts for the design of each member. Okay. So one thing that I always see, so we cannot see the formulas precisely because I only use the viewer from the Google Drive. But if you open it, you will see. If you open this using PDF viewer, you will see them. Okay. So now, one thing that I always observe when others are submitting is that they use 2001. So that's an evidence that you only copy and paste the flowcharts. Okay. So I want you to make your own flowcharts as to how you go around with the design. So well, the thing here is you don't really have to worry much about this because usually when I discuss design, I always uh, I always discuss the step-by-step procedure as to how you go around with them. Okay, so meaning as long as you follow as long as you follow what I present during the lectures, you will be able to make your own flowcharts. Okay, so and then structural analysis. No, so you summarize the loads. Although it is already on chapter 2, you still need to put them here. Although it should be more summarized. It should be a lot shorter because this will be inputs. Okay, and then the load combinations that they use, and then they do the analysis and design for each trade-off, and then they have the trial sections, and then they analyze it, the actual forces, the shear forces, uh, torsion, the bending stresses, although we cannot actually see them here. Ayan, right there. And then, based on the analysis results, you will now perform your design. These are all part of the structural analysis. So here, so these are the reactions, the column forces, beam forces. So per columns, they usually only pick the maximum minimum. Okay. Same thing with this. And then they also check for the displacements. So I think they pass the drift requirements. No? So it is an wind and earthquake load sections. No? So you do not just have to present the drifts. You need to check if it passes the code requirements. Okay. So I think it's L over 240. L is the height of the story from the ground. No? So you just need to check the NSCP specification for drift. Okay. So and then they have the design results. Hmm, I think they did the manual. So you will do this manually. So they did not show it here, no? But then in appendices they have their manual calculations, no? The Excel files for this. So that would be fine, no? So if you want to show the detailed calculations, you can put them as appendices, no? Well, you don't really submit a hard copy, so it doesn't matter how many pages would you take. In this particular case, uh, they they went up to 1,300 pages precisely because their appendices they put pretty much everything there. Okay, so once you have this one, so you do the analysis and design for all the four trade-offs. Okay, and then you do the final rankings, and then whatever would be the result, that would be your final design. So in this case, they have trade-off 3. So this one. So this one would be the winning design. So the final design, you will now make your plans based on the based on the final design. Okay. So and then the details on how you do say the connections and all. So they also have it here. So then the references, and then these are the appendices. No? So everything that you did here, you will put it here. Okay. All right. So do you have any questions about the design? So if you want to see more about the samples, you may access the Google link that I have given yesterday evening. Okay. So again, do you have any more questions so far?